Hi everyone, today we're going to go over lesson 4-2, which is solving quadratic equations by graphing. So let's start with our first example. We're going to solve x squared plus 6x plus a equals 0 by graphing. So we're first going to graph our function. We can do this by knowing that our axis of symmetry is negative x equals -3, making the table of values using -3. We're then going to graph each point. But from our table, we're going to use the x values -5, -4, -3, -2, -1. And then from that, we get the y values 3, 0, -1, 0, 3. So we go ahead and plot this, and we can see that on this function, the zeros are -4 and -2. So when we're looking for solutions of quadratics, you might also hear what are the zeros, what are the solutions, what are the x-intercepts. Those are referring to the same thing here. So our solutions are where they cross the x-axis, which is x equals -4 and -2 here. We can also check this by plugging in -4 and -2, our original equation, and making sure we get a true statement of 0 equals 0, which we do. So go ahead and try solving x squared by plus 2x minus 3 equals 0 by graphing. All right, so looking here, when we graph it, only one of these graphs are actually correct. The first thing we're going to do is actually cross out what we know not to be true. Since our a value is positive, we know it opens upward. So we would cross out C and D. Then we would go ahead and graph that, and we would find that it crosses at -3 and +1. You can again graph this in Desmos and look at the graph there, look at the table, or you can go ahead and come up with your own values and test them. When we're looking with quadratics, we have three possible answers. Either we're going to have one real solution where it crosses the x-axis once. What's really happening there is that the vertex is on the x-axis, so it touches and goes right back up or down, depending if our a value is positive or negative. Two real solutions, if it opens up or downward and crosses twice on the axis. And then our last option is there's no real solution, and this would be when it is opening in a direction opposite of the direction of the axis, and it just never touches the x-axis. You will always have a y-intercept, but you might not always have an x-intercept is one of the key things here. So when you take a look at our next one, we have x squared minus 4x equals -4. We're going to solve this by graphing. To graph this, we need to go ahead and move over one of the values or two of the values, however you would like to look at it, so that we have our equation in standard form. So to do this, we're going to go ahead and add 4 to both sides so that we end up with x squared minus 4x plus 4 equals 0. We're then going to graph the related function of x squared minus 4x plus 4. And here is a table of values that we could use to plot. We have 0, 4, 1, 1, 2, 0, 3, 1, and 4, 4 as coordinate points. So if we were to graph this, we notice that there's only one intercept. It touches at +2 and turns right back up. So the only solution is 2. Right, go ahead and work on this one. Solve x squared minus 6x equals -9, and go ahead and graph your answer. All right, so working on this one, I can already tell that B and D won't work out because it will end up facing upward when we graph x squared minus 6x plus 9. And with that, we get A as our answer. It touches once at +3. Next, we have a number theory problem. So we're going to use a quadratic equation to find two numbers with a sum of 4 but has a product of 5. Um, so we're going to let x be one of those numbers, and the other number will be 4 minus x. So we know we're saying the reason we have 4 minus x is because that when we add x to it, we would get 4. And then we're going to use the product x times 4 minus x to equal 5. So we're going to go ahead, distribute property with x to get 4x minus x squared. We're going to move over 4x and negative x squared to the other side to get x squared minus 4x plus 5. And we are going to go ahead and graph this function. So when we're graphing it, we notice that it never touches the x-axis, so it will never touch. That means there are no numbers that we can combine to get a sum of 4 and a product of 5. And you could try using several numbers to get this, and you'll find that none of them work. So next, we're going to use a quadratic equation to find two numbers with a sum of 7 and a product of 14. So go ahead and try that one. All right, so for a sum of 7, we're going to use x and 7 minus x. For our two terms, we're going to multiply these, and when we multiply them, we should get 14. So we get 7x minus x squared equals 14. And it doesn't matter if you want to move the 14 over or the 7x minus x squared to the other side. I'm going to go ahead and move the 14 over and change it to standard form of x squared, negative x squared plus 7x minus 14. And then by graphing these, we can come up with our answer. So when I graph it, it's going to be upside down. I need to go over here, so it's going to be here and here. And it should look something like that. Here at 2 and here at 5. Oh, oops. So actually, if we actually graph this, which we can go ahead and use Desmos to do that. Pause. So we're going to go ahead and do a new share, and we're going to go to desmos.com. And we're going to go ahead and graph our equation of negative x squared plus 7x minus 14. And as we can see, it's never going to touch, so there is no solution here. So that's why we have no such numbers exist. For our next example, we're going to solve negative x squared plus 4x minus 1 equals 0 by graphing. If exact roots cannot be found, we're going to state the consecutive integers between which the roots are located. So this is one of the things, depending on what you're using, you do need to read the directions very carefully. These were designed to be using the TI, the older TI calculators for when you graph things. So we're going to go ahead and graph, and here we can see that we have a change in our y values and the signs using this. So we have 0, negative 1, 1, 2, 2, 3, 2, 3, 2, and 4, negative 1. What we're looking for here is the change in sign. So this went negative to positive, and here we went positive to negative. My answer is going to be between 0, 1, and between 3 and 4. And so when we graph it, we can actually see there's not a clear answer. So you need to read the question to see how they want you to answer it. If they tell you they just want you to go ahead and tell me what two values between which it is between, then you need to go do that. If they want exact roots, they'll tell you that. So do make sure you read the question. Um, but in this case, they tell us to list the consecutive integers for which we cross between. So 0 and 1, and then 3 and 4. So go ahead and solve x squared minus 4x plus 2 equals 0 by graphing. What are the consecutive integers between which the roots are located? All right, so let's go ahead and take a look at this one. We're actually going to go ahead and use Desmos again for this problem. So we're going to switch over to Desmos. And we're going to graph x squared minus 4x plus 2. And as I can see, they're between, they're not going to give exact. And there's no way for me to actually at the moment tell if these are truly the exact answers or rounded. So we do want to go ahead and say, well, I know 0.5 is between 0 and 1. I know 3.4 is between 3 and 4. So with that, that's how we're going to take a look at write our answer, since that's how they're asking us to respond to it. And with that, our answer is A. All right, for our next example, we have you solve a real world problem. The highest bridge in the US is the Royal Gorge Bridge in Colorado. The deck of the bridge is 1,053 feet above the river below. Suppose a marble is dropped over the railing from a height of 3 feet above the bridge deck. How long will it take the marble to reach the surface of the water, assuming there is no air resistance, using the formula negative 16 t squared plus h sub 0, where t is the number in seconds and h sub 0 is the initial height above water in feet. So we need to know to find the value t when h sub 0 equals 1056. So we're going to set 0 equal to negative 16t squared plus 1056. We're going to go ahead and graph this, and we're going to actually use this in Desmos. And do make sure that when we graph this in Desmos, we use x instead of t. So you can do y equals negative 16 x squared plus 1056. So we're going to go back to Desmos, do negative 16x squared plus 1056. And as we can see, we have two different answers. We have a negative and a positive, but they're both the same. When we're looking at this, we're especially looking at time, we're going to look at our positive answer because it's being when it's dropped from. And if we actually zoom out, we can see how high that is, and you can see it's quite high up there. But about 8 seconds is how long it will take for it to cross. Here's a graph using an older end spire. We can see again it crosses just around 8. So it takes approximately 8 seconds to hit the water. All right, here is your problem. Go ahead and try solving how long it would take the marble to reach the water. All right, so here we have one of the largest dams in the U.S. is the Hoover Dam on the Colorado River, which is built during the Great Depression. The dam is 726.4 feet tall. Supposing marble is dropped over the railing from a height of 6 feet above the top of the dam. How long will it take the marble to reach the surface of the water, assuming there is no air resistance, using the formula negative 16t squared plus h sub 0, where t is the time in seconds and h sub 0 is the initial height above the water. So this is very similar. So we need to know how high the marble is when we start. I know it's 726.4, but it's also, we need to make note, they told you it's also 6 feet above that. So what we're going to have for h sub 0 is 732.4 So that means I'm going to graph y equals negative 16x squared plus 732.4. So we're going to go back to Desmos. Luckily, I already have negative 16x squared, and we're going to do plus 732.4. And we get 6.766 seconds. And looking at my answer choices, 6.776 with rounding, that gets us to 7. So it's about 7 seconds. That is the end of our notes for 4-2. I will see you next time.